Hello and welcome to another one of D's ADD videos. Today we're going to be looking at relative versus absolute extrema. How do we go about finding them and what they are? Alright. A relative extrema is any point that has a increase then a decrease, okay, or a decrease and then followed by an increase. And the points in between here, these are called your critical points. And you find your critical points a couple of ways. This is both for relative and absolute extrema. One way is by finding the first derivative and then setting it equal to 0 and solving. And the other way is by looking at any point that is not differentiable but continuous. Okay, so what we need to be doing is for both absolute and relative extrema, we will be taking the first derivative, setting it equal to 0 and solving. Also looking for anything that was okay in the first function, the original, but then when you, let me change that x to a number, or a c value, any constant. So f of c is okay, but f prime of c is undefined. That's what that means up here. Okay, and that's how you get your critical points. So what is the difference between a relative and an absolute? Well, relative extrema are going to be any one of those increases and decreases. So if it goes up then down, that's a relative max. And then if it goes down then up, that's a relative min. Now if we're doing absolutes, absolutes usually require endpoints, and endpoints will dictate the range of your function, or the domain of your function that you're interested in, and you will be looking for the largest and the smallest. Actually, let's just extremate on this. So we're going to look for the largest y value and the smallest y value. So how do we differ in their techniques? Well, here in the absolute extrema, you're going to find your critical points using this method that I just went through here, and then you're going to plug those into your original function. And look for the largest and smallest answer. The largest answer is going to be max, and the smallest is your min. Alright, and then if we're doing the relative, you're going to do the first derivative test. Actually, you're going to first find your critical points, and then you're going to do the first derivative test. So find CP's. First derivative test. What is the first derivative test? Well, this is relative extrema continued. Well, I prefer a number line. Some people use a table, but you're gonna draw a number line and plot all CPs and vertical asymptotes. Okay, so you'll have something that looks like this, where some of them will be dots, and let's do a different color. Some of them might be dots, where another one might be an asymptote. Okay, and what you're going to do is you're going to plug in a number to the left and the right of each of your critical points or your asymptotes. So you're going to do a test point here, a test point there, a test point there, and you're going to plug them all into the first derivative, hence the name first derivative test. And then if you get an answer that's positive in your first derivative, that means it's going to increase. I usually do a diagonal arrow up like that for the increase sign, and then a minus sign means it's going to decrease. You should do one of these for that. So if you see something that looks like this, then like that, provided it's not an asymptote here in between, it's going to be a relative max. And then if you see down then up, in between those two arrows is going to be the lowest point or relative min. Alright, so again, either find critical points, plug them to the original for absolute extrema, or for relative extrema, find the critical points and do a number line in which you have your critical points here. And this is a vertical asymptote. Just in case you forgot, you set the denominator equal to 0 of your f of x to get your VA. Alright, so make sure you check out the example video for both absolute and relative extrema. So in this case, your absolute max would be this point right here, this critical point, and your absolute min would be this critical point. So it just happen to be both relative mins. This bracket could have been, this function could have instead done something like that, gone lower, and this endpoint could have moved over here somewhere, not necessarily a min, and then that endpoint would have been your minimum because it's lower than this y value here. Alright, hope that made sense. So basically the point was that you don't necessarily need a critical point to be your absolute minimum. Okay, for relative you do, but not for absolute. So watch the example videos, practice, practice, practice. Thank you and have a nice day.